So we are going to start graphing polynomial functions now. So when we graph a polynomial function, there are three things that need to be accurate on your graph. The first thing that needs to be accurate is that the end behaviors need to be going in the right direction. The second thing that needs to be accurate is that you must have X-intercepts correct and the correct behavior at the X-intercepts, and you must correctly state the Y-intercept. Do you have to show graphically all of the units to the Y-intercepts? No, but you need to have the point named, okay? So those are the three things that must be accurate. The rest of the shape, okay, is going to be just a rough sketch. So our first that we're going to graph is f of x equals x minus 1 times x plus 3 squared, okay? So that's what we're going to graph first. Now, what's important are these three pieces. So the first thing that's important is naming the end behaviors. So we've got the left end behavior and the right end behavior. Now, you don't have to write out, unless it specifically says write out its end behavior in proper notation. If we're just trying to graph, I'm just quickly trying to think about what my right end should be doing and my left end, so I don't need to use proper notation here. But let's remember what is entailed in end behaviors. What matters? Well, what matters is it an even degree or an odd degree? And is the leading coefficient positive or negative? So notice, this is in factored form, okay? So remember, leading coefficient and even odd degree, the degree is all based on when you're in standard form. So one way to do this is linear, okay? This is x minus 1. This is x minus 1 times x plus 3 times x plus 3. So if you were to FOIL, I'm sorry, not just FOIL, but distribute and put this thing in standard form, this term times this term times this term would be giving you the leading term. Okay, if you take the leading term of each factor, it tells you, when you multiply together, it tells you what the leading term of the entire polynomial would be in standard form. So the leading term would be x to the third. So this is an odd degree, and the leading coefficient is positive. So that means odd degree means they go in opposite directions, and a positive leading coefficient means the right end would be going up. So I'm not going to use proper notation. I'm just going to make a note for myself that the right end should be going up, and the left end, because it's odd degree, means the opposite. It should be going down. Okay, so that's my info about my end behavior. I'm going to write it down, and then I'll translate it to a graph once I gather all of my information. So I did my end behavior. Now, x-intercepts are the values of x when the output is 0. So 0 equals x minus 1 times x plus 3 quantity squared. Okay, so it's already factored for you. That's really good, because now I can just use the zero product property. First, think about how many unique x-intercepts do we have. We only have 2 unique x-intercepts, okay? We have x equals 1, and we have x equals negative 3. Now, what matters is the behavior at the x-intercept, and that's based on the multiplicity of the root. So, did you see the factor of x minus 1 how many times? Only once. So this was a single root of 1, which means it just behaves like a linear, which is going straight through. X plus 3, how many times did you see that factor? Twice. That means this is a double root of negative 3, and it behaves like all double roots, right? Like a quadratic, where you see that bounce, okay? And the y-intercept is what's the value of y when x is 0. So f of 0 equals 0 minus 1 times 0 plus 3 squared. That's going to be negative 1 times 3 squared. Order of operations do 3 squared, so that's negative 1 times 9, so that's negative 9. So the y-intercept is the point 0, negative 9. Okay, so I don't put increments on my y-axis at all. I just put them on my x. So the only time you should be hitting the x-axis is twice, at negative 3 and at 1. So at negative 3 and at 1. Now, after the rightmost x-intercept, that's your right end behavior. So your right end should be going up, and after the leftmost x-intercept, that's your left end, and your left end is going down. Now I draw left to right. Okay, so I'm going to start down here, and now I have to go through and get to my x-intercepts. Except I have to make sure I follow the correct behavior. So at x equals -3, I should look like a quadratic. I should look like a bounce. So that means when I come up, I don't go straight through. I hit the root and I come back down. Okay? Now I stop and I say, okay, I need to get to that x-intercept next. You only turn one time. You don't just make millions of turns in between. That's something else that we'll talk about, okay? This, you turn one time, okay? Now, before you hit that next x-intercept, you have to say to yourself, okay, at 1, what's the behavior? I should be going straight through. It should look linear at that x-intercept. So I'm going to go straight through, okay? And notice I have to end. I put these little markers here so that I remember what my behavior is, okay? Now, notice, the y-intercept is -9, okay? I'm not going to draw 9 marks. I already have the point listed right here, okay? So there's no point in doing that. So this is what the graph of x minus 1 times x plus 3 quantity squared looks like. Look, at x equals 1, it looks linear at the root, and at x equals -3, it looks like a quadratic at the root. So that is number 1. Now let's move on. Let's do another one. Number 2. Let's do. Actually, oh yeah, why not? Okay, so y equals negative times x plus 4 times x minus 1 squared times x plus 2 to the 3rd power. All right, so first thing, we've got our end behavior going on. I put y there instead of f of x, that's okay. So let's worry about our end behavior first. So we need to know about what's the leading term in standard form. So we've got -1 times, and this is x plus 4, so the leading term there is x. This is x minus 1 times x minus 1, right? So that's really x squared there. And this is x plus 2, x plus 2, x plus 2, so that's x to the 3rd there. So the leading term would be -x to the 6th power. That's the leading term of this polynomial. Make sure if you're in factored form, you can think about the leading term in standard form, okay? So the left end behavior and the right end behavior, remember, is all going to be based on if this is an even degree or this is an odd degree, okay? And is the leading coefficient positive or is it negative? So the right end behavior, okay, if it's a, first think about, okay, even degree, odd degree. The degree is 6, so that's even. That means they're going in the same direction. And now the right end is based on, is the leading coefficient positive or negative? It's negative, so the right end goes down, and the left end matches it, so it goes down. So next, we have our x-intercepts. Okay, so to get our x-intercepts, we set y to be 0, the output, right? And woof, we're in factored form already, which means we're ready to start finding our x-intercepts, right? This is a constant value of -1. It doesn't have the ability to change, so we can't do anything there. So what makes x plus 4 equal 0? -4. Was this a single, double, or a triple root? Well, did we raise this power to the first, the second, or this factor to the first, second, third, fourth, fifth? The first, right? So this is a single root of -4, which means the behavior at the root is just you're going straight through it. Now, x minus 1, what makes x minus 1 0? 1. So is this a single, double, or triple? It's a double. So what's the behavior going to be here? It's going to look like a quadratic, so it's going to be a bounce. What makes x plus 2 equal 0? -2. Is this a single, double, or a triple? It's a triple root, so it's going to behave like a cubic at the root, which is that leveling or the snake, whatever you want to call it. And now our y-intercept is going to be negative times 0 plus 4 times 0 minus 1 squared times 0 plus 2 to the 3rd. I can't tell you how many times students just tell me this is 0, 0, 0. No, it is not. Order of operations, do inside the parentheses first. 0 plus 4 is 4. 0 minus 1 is -1 squared. Okay, then the squared is on the outside. 0 plus 2 is 2 to the 3rd. Now you must take care of exponents. So negative 1 to the second is 1, 2 to the third is 8. So this is now negative 1 times 4 times 1 times 8, that's negative 32. Your y-intercept is the point 0, comma, negative 32. Okay, so how many unique x-intercepts do we have? We have 1, 2, 3 unique x-intercepts. Where are they? One's at negative 4, one's at 1, one's at negative 2. You should not touch this axis any more times. If you end up going through and making any more x-intercepts when you are trying to connect them, that means you are doing something wrong. That means probably your end behavior is wrong, or you're doing the wrong behavior at the roots. So let's see, the right end needs to be going down. So after the rightmost, I should go down here, and after the leftmost, I should be going down. Okay, so remember, draw this graph. I think it's easiest to draw it left to right. So let's look at negative 4. It's straight through, so it's going to be like this. Got to go straight through, right, coming from down. And now I turn once to get to the next root, but I'm going to stop, and I'm going to look. Negative 2, I need to level. So I need to look like a cubic going through here. So I go like this, and I go like that. Look at that curve there, okay? So that's a level. Try and make it as best as you can. It should, if you were to zoom in, it should look like a cubic function there. And now I have one more x-intercept. So that means between any two consecutive x-intercepts, you should only be turning once when you're graphing these, okay? If you have only real roots here. So I gotta turn one time, but notice, I don't wanna draw too much because I need to be able to turn and I have to see what my behavior is here. I have to bounce. So that means I have to come up, I have to hit that root, and I have to come back down. Okay, you don't want to go straight through. Remember, if this was a double root of 1, I need to behave like a quadratic there. So this is the graph of number 2. Okay, let's do another. Number 3. Y equals x times 2x plus 1 times x minus 4. Okay? End behavior, we'll start there. So all that matters with the end behavior is even degree, odd degree, leading coefficient positive or negative. It's in factored form. So we have to think about what would be the leading term in standard form. So the leading term here is x. Leading term here is 2x. Leading term here is x. That's going to give us 2x to the third power. So the leading term is 2x to the third power. So odd degree means opposite directions. Leading coefficient is positive, so the right end is going up and the left end is going down. Now we get our x-intercept. So we set y equal to 0. Okay, so it's in factored form, very good. How many distinct x-intercepts do I have? I have 3. Notice this term, this factor out here, is a variable factor, which means it is an x-intercept. What makes x equal 0? 0. How many times did you see the factor of x? Once. So this is a single root of 0, which means you would be behaving straight through. 2x plus 1 equals 0. What makes that 0? Negative 1/2. How many times did you have this factor? Once. So this is a single root, which means the behavior straight through. X minus 4 equals 0. So what makes this 0? 4. How many times do you have this root? Once. Is this a single, double, or triple? This is a single. Behavior straight through. You have 3 distinct x-intercepts here, okay? The y-intercept, 0 times 2 times 0 plus 1 times 0 minus 4. This is 0 times 2 times 0 plus 1 is 1 times negative 4. So now you have 0 times 1 times negative 4. Now your y-intercept is 0, 0. Okay? You only touch the x-axis 3 times. Negative 1, 1, 2, 3, 4, 5, 2, 3, 4. Okay, so the right end after, well, first get your X-intercepts on there first. That's the first thing you should always do. So x equals 0, x equals -1/2, and x equals 4. So the right end should be going up, and the left end should be going down. So after the leftmost one, it goes down. So now, look how close these two x-intercepts are. That means you really need to be thinking ahead before you start graphing this thing. What should I be doing at -1/2? I should be going straight through. So I'm coming down, I'm coming up, I'm going straight through. I have to turn once, and what's my behavior at 0? Straight through. So notice, both of these look, if you were to zoom in, they look linear there, but you had to turn once to go back through. Now, I've got to turn again. Notice, I don't care. Everything in between doesn't matter to me. So if you take this and you start turning now, that's fine. If you, because you went up so high in your pencil, maybe you came down a little bit more, that's fine. But you should only turn one more time between this x-intercept and the next one. Okay? Where you turn doesn't matter, and how far down you turn doesn't matter. And then what should be your behavior at 4? Go straight through. Whoop. Okay? So nice and smooth. You went straight through all of them, and then go back and check. Did all of this add up? If you somehow came back and went like this, right? This would be wrong because you just now added 2 other x-intercepts. But we know that those shouldn't be x-intercepts because they're not factors in this expression of the equation of the problem that we were graphing. Okay, we're going to do 3 more. Number 4, f of x equals x to the 3rd plus x squared minus 9x minus 9. Okay, so first thing is end behavior. If you notice, look, this is in standard form already, so you can pull out the leading term. The leading term is x to the 3rd. So we can get our end behavior, the right end, okay, and the left end are going in opposite directions because the degree is odd, and the leading coefficient is positive, so that means the right end goes up and the left end goes down. Now for our x-intercepts, we need to know what's the value of x when the output is 0. Well, I can't find them right now because I only have it in standard form, and we don't have a magic 3rd degree formula that's going to shoot out our 3 values. So what do we have to do? We have to factor this expression down to linear and quadratic factors. So if there are 4 terms, you should be factored by grouping here. So that's x to the 3rd plus x squared plus -9x minus 9. That's going to be x squared times x plus 1 minus 9 times x plus 1. That's x plus 1 times x squared minus 9 equals 0. Can you factor that further? Yes, that's going to be 0 equals x plus 1 times x plus 3 times x minus 3. So look at that. Okay, I'm going to write up here. X plus 1 times x plus 3 times x minus 3. Okay, so I can see I'm going to have 3 distinct roots. Okay, what makes x plus 1 equal 0? -1. Was this a single, double, or triple root? Single, so I'm going to go straight through. What makes x plus 3 equal 0? -3. Single, double, or triple root? Single, because you only see the factor of x plus 3 once. So what's the behavior? Straight through. What makes x minus 3 equal 0? When x is 3. Single, double, triple root? Depends on how many times did you see the factor. You saw it once, so it's a single root. So you're going straight through. Okay? Your y-intercept is going to be what is the x when what is y when x is 0? So 0 to the 3rd plus 0 squared minus 9 times 0 minus 9. That's going to be -9. So your y-intercept is 0, -9. So plot your x-intercepts first. One's at -1, one's at -3, one's at 3. At the right end, you're going up. At the left end, you're going down. And all 3 of them, you're going straight through. So you got to come up, You got to turn once to get to the next one. You got to turn one more time to get to the next one. And you're going straight through all three of them, sorry. All right. Number 5. Number 5, f of x equals negative x to the 4th minus x to the 3rd. Okay, so we start by getting the end behavior. Notice we're in standard form, so I like standard form better for getting the end behavior, but standard form is not going to help us when we have to get our x-intercepts. So this is in standard form. We can see the leading term is negative x to the 4th. The degree is even, right? And the leading coefficient is negative, so the degree being even means they're going in the same direction. The fact that the leading coefficient is negative means the right end goes down, so the left end goes down. X-intercepts are going to be what are the values of x when the output is 0. So 0 equals negative x to the 4th minus x to the 3rd. This is a 4th degree polynomial, which means you need to factor this thing down. I'm not going to ask you to graph anything if that would have imaginary roots. Everything you graph has to have real roots. Otherwise, you wouldn't be able to sketch it. So first thing you always look for when you're factoring, okay, is what's the greatest common factor? The greatest common factor here is negative x to the 3rd. If I factor out a negative x to the 3rd, I'm going to be left with x plus 1. This is the factored form. Now, don't get confused here, okay? When you have factors that are raised to powers. This right here, negative x to the 3rd, this is negative x times x times x. So this is 0 3 times. So this is a triple root of 0. Don't get confused with this, okay? You factored it. If you can factor, you want linear quadratic factors. So you have a linear factor of x 3 times here. Don't get confused. You have a linear factor of x 3 times. So then you have x plus 1. What makes that 0? Negative 1. How many times do you have this factor? Once. So this is straight through. But this 0 is that level behavior because you have a triple root. Then what's the y-intercept? So negative 0 to the 4th minus 0 to the 3rd. That's going to put you at 0. So the y-intercept would be the point 0, 0. Always plot your x-intercepts. 0. How many distinct do you have? You have 2 distinct. You should never hit the x-axis more than these 2 points. If you're hitting it more than those 2 points, you're doing something wrong. So the right end goes down. After the rightmost x-intercept, you should be heading down. And after the leftmost, you should be heading down. And at negative 1, you should be going straight through. And at 0, you should be leveling. So I should be going straight through. I have to turn once so I can hit this. And I have to do that level behavior. Okay, so try your best. Look, that's not even going to be a function. Wouldn't pass the vertical line test, okay? And do your best. If you think that you are not good at making your level, what you can do is point to it and write that that was supposed to be a level. Now, if that's supposed to be a level, that means if you were approaching it from above, you better be approaching it from below. You should better be below once you go through it, okay? If you say level and you draw this, if you say it's a level and you draw this is really wrong because I can't accept this because you should be coming out the other side, okay, of the output values. Okay, so that was number 5, and we're going to do one more. Number 6. Okay, number 6, you have the standard form of f of x of the function you have to graph. So we start with the end behaviors. Oh, I forgot to I'm giving you a hint. I'm going to tell you that Negative 2 is a root of f of x, okay? So that doesn't really mean anything for us in terms of the end behavior, okay? What's the leading term here? The leading term is x to the third. Now if I told you that when you're graphing you have no imaginary solutions at all, that means all three of your solutions here are real. I say solutions because that's the same as roots, right, when we're finding our x-intercepts. Now, degree is odd because this is 3, and the leading coefficient is positive, so the right end goes up and the left end goes down. Now to get your x-intercepts, that's when you set x to be, what's x when y is 0? So you would go to factor this, but this is not factorable. So this is your helpful hint. One of your x-intercepts you already know. That's what root means, right? So you know one of your x-intercepts is already negative 2. So you know that one of the factors is x plus 2 because you're getting a root of negative 2. So now what we have to do is, what's the other factor? So what do? We divide here. So this is actually going to be a bit of work. So I'm going to use synthetic division. Check, do I need any placeholders? No. So 1, negative 1, negative 11, negative 10. Bring down the 1. 1 times negative 2 is negative 2. Add that. You get negative 3. Multiply. You get 6. Gives you negative 5. Multiply that. Gives you 10. 0. It better have been 0 because you know that negative 2 is already an answer. So you get x squared minus 3x minus 5. Now, you can't factor this anymore. I can't think of two numbers that multiply together to give me negative 5 and add together to give me negative 3. But I can still get my solutions from here because anything, as long as the factor itself is linear quadratic, I know how to solve it. So what this means is I'm about to get values, okay, that are probably irrational, okay? So I have to use a quadratic formula. Negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 5 all over 2 times 1. So that's going to be 3 plus or minus the square root of, and I'm going to get the discriminant now. Whoops, that's a negative, right? So it's going to be plus the square root of 29. And now, I need to graph these. These are x-intercepts, so I need to round this. I need to see what the square root of 29 is to 3 decimal places. And that's going to give me 5.385. So now let's get our 2 x-intercepts. So what's 3 plus 5.385, and then divide that by 2, that's 4.193. And then what's 3 minus 5.385 divided by 2? That gives us negative 1.193. So how many times did we get this as a root? Once. So this is a single, so we're going straight through. How many times did we get this? Once. This is a single, we're going straight through. Okay? So notice, we have 3 single roots here. We have negative 2, we have 4.193, and we have negative 1.193. So the last thing we do here before we sketch it, okay, I'm just erasing to give some room. I'll just write, that was the note we had. Okay, get the y-intercept. We're in standard form, right? 0 to the third minus 0 to the second minus 11 times 0 minus 10. That's negative 10. Our y-intercept is 0, negative 10. So when we sketch this, remember, I don't care about the y-intercept having the increments there. What I care about is making sure your end behavior and your behavior of your intercepts is correct. So 1, 2, 3. 3 times you touch the x-axis, and that's it. So once at negative 2, and then at 4.193, and at negative 1.193. So we're pretty close here, so be very careful when you do this. Right end goes up, left end goes down. I want to keep in mind my behavior at both of these. At both of these, I'm going negative 2, right? We only saw -2 once, so this is single root, so straight through. So I'm going straight through. I gotta turn once. I'm going straight through, and I'm going straight through. Okay, so that's graphing polynomials. What you have to keep in mind is end behavior, X-intercepts, and behavior at the X-intercepts, and the Y-intercept. Never touch the x-axis more than the number of unique X-intercepts you have. If you are, then you are sketching it incorrectly. Always go back and check to make sure it makes sense. Did you finish right end up, left end down? Yes. Did you only touch 3 times? Yes. Did you go just straight through all of them? Yes. Remember, between any 2 X-intercepts, any 2 consecutive X-intercepts, you should only be changing direction 1 time.